Welcome, friends. So, in this particular lecture, we will shift our gear to AWS. In the last couple of lectures, we actually formed a Docker image in Python. That particular image can spin up one container. That container is the My App application, and that can communicate with one MySQL server. And that particular application can fetch the data from that MySQL server and as well as can put the data into that database. So, in a short, that particular application could able to communicate with the database server. Now, this particular Docker image, we are going to deploy in AWS environment. And in the AWS environment, we will use the ECS, the Kubernetes service, Elastic Container Service. ECS is the container orchestration service in AWS. So in upcoming lecture, we will see what are the different features ECS does, and we will discuss further about ECS. Now, in this particular lecture, we will actually deploy our Docker container in AWS ECS Fargate environment. This Fargate is completely serverless. So let's get started. So this is our architecture. We are going to deploy our My App Docker container in the ECS Fargate environment. And this particular ECS Fargate service will fetch the Docker container through the internet gateway, and it will have this container spinning into this ECS service. As well as we are using a RDS MySQL database. This RDS MySQL database will be created in a private database subnet group. So no one from the external world can access this MySQL RDS database, but this particular RDS database can be accessed by our My applications written in Python, and that is spinning up in the container inside the ECS Fargate environment. Only this ECS service can fetch the data and can put the data in RDS MySQL database, but no one else from the outside. Now, this entire VPC is basically My App Secure VPC. The user will send a request to a load balancer, and this particular load balancer will balance the load between the different tasks or container inside the ECS Fargate environment. Now, what we will do in this particular lab, we will drop the connections from the outside world for this ECS environment. There will be 3 security groups assigned over here. This particular security group is assigned for database, and this database security group will allow the access for the database from the ECS service only, and this ECS service can access this RDS MySQL database from 3306 port only. This ECS security group, on the other hand, can only accept the connection from this load balancer security group and only 5,000 port, because our application will be running from containers 5,000 port, and these 5,000 ports can be accessible through this ECS security group. On the other hand, this load balancer security group can accept the connection on port number 5,000 from the external world. So apart from these 5,000 port, no one can access this load balancer even. And the external world cannot reach to this ECS environment or the RDS MySQL database in any manner. So hope this architecture is clear now. Now let's jump to the console and let's see all in action how we can implement this architecture in our AWS environment. So let's get started. Now, friends, this is our AWS management console. And over here, first and foremost thing, we will create a couple of roles. First and foremost, we will create the roles for ECS task. So we will go to this IAM and we will create the role. Let's go to this role and create the roles for ECS service. So it's an elastic container service task, which will be trusted. And over here, what exactly we will do? We will search for AWS Lambda basic execution role. Now, why we are using this AWS Lambda basic execution role? Because this is the role that will actually help this ECS to log everything inside the CloudWatch log. So this is one of the policy that we are going to choose. And other policy we will use is Amazon RDS data full access. Now, through this particular policy, this role will able to create and select and delete data from RDS database. So click next. Now we are going to keep the role name as ECS task role. Now allow the ECS task to call RDS and Cloud Watch logging service. And we are fine with AWS Lambda basic execution role and Amazon RDS full access role. And let's create this role. All right. So our roles are created. This is our role. And now let us create a complete secure VPC. So let's go to this VPC console now. And let us create one brand new fresh VPC for this complete activity. So let us create the VPC and let's create it as VPC and more. And over here, we will have this with two availability zone that is completely fine. And two public and two private zones. We don't need any NAT gateway. We don't need any VPC endpoint. Let's create these VPC. All right. So our VPC is created. Now we can see our VPC are having spread across two different zones, that is East 1A and East 1B. And also we are having these route table associated with that. And these blue subnets are actually the private subnets, and these green subnets are the public subnets. Now, what we will do, we will go to this security group right now. Now, this security group is on EC2, and let us create a separate tab. And we will create three security groups, as we said. One is for database, one is for load balancer, one is for ECS. We will go to this left panel and go to the security groups. And over here, let us create one security group. Now, this particular security group will be created for our My App Secure VPC. Now, this security group name will be Load Balancer Security Group. We can say Load Balancer Security Group can external world can reach to the load balancer at port 5000 because we are going to use the 5000 port for our application. So what we will do, we will add an inbound rule and we are going to say 5000 ports will be open for entire world to these load balancer security group. So our load balancer security group is created. Now let us create another security group. And this security group will be for ECS security group. And we can say ECS security group and we can say security group for ECS Fargate to open the port from load balancer security group. Now, here, this particular thing again will need to be created under my app secure VPC. Now, here is some trick. So let's do one thing. First, we are going to open this 5004 for our load balancer security group. So we can say load balancer security group. And for now, we are also going to open all TCP port for the entire external world. Now, this is our temporary settings we are doing, and going forward, once our Docker image will be fetched inside the ECR, we will actually drop this second rule. So for now, this particular ECS security group is actually open to public. And as well as we are having a custom rule to accept the 5000 port from the load balancer only. So let's create this ECS security group as well. Just make sure right now we are having two inbound role. One is completely open for the external world and other one is a secured one that will only allow the access from load balancer on 5000 port. So later we will drop this particular inbound rule. Now let's create the hard security group that is for the database. So it is for database security group and allow the access from 3306 port from our ECS containers or tasks. Okay. And this is again for my app secure VPC. And here we need to open 33064 and this time we will say ECS service group and only we are going to open the port from ECS load balancer, ECS security group. Let's create the security group. Now, our security groups are ready. We are having three security groups, one for database, one for load balancer, and other one is for ECS. Maybe we can filter this for easy access. And let's move to RDS subnet group. Let's go to this RDS console and we will go to the subnet group. Now we are going to create one DB subnet group and this is DB private subnet group just to make sure that our subnets are not spanned across the public region. This is again for our secure VPC and just see these VPC dashboard. We are having these my app secure VPC created, and we are having this subnet is spanned across two zones. One is US East 1A and 1B. So let's select 1A and 1B only. And over here, make sure that we use these private ones. So only the blue ones. The blue ones is basically you can open this blue one over here and you can check the subnet which is ending as BD49BC. So make sure that BD49BC and as well as this one, this blue one, we can open this in another tab and we can make sure this is CD49BB. So CD49BB, this one. So we are going to span the subnet group on these two private zones. We need to provide the description as well, so we can create. Our subnet group is created. Now go to this dashboard and create the DB instance. Let's create the DB instance. Now we are going to create a very easy database, but we need to keep it secure. That's the only motive we have in this lab. So we are fine with the engine version 8.0 and make sure that you have selected MySQL, by the way, and we are fine with free tier 1, which is the basic one, and we can keep the user name as admin. Noted that, and we are going to provide the master password as root 12345 6. Okay, and over here we are fine with dbt3 micro instance. 20 GB is quite good. Now over here, we change these VPC to my app secure VPC, and this subnet group we just created, DB private subnet group, which is spanned across two availability zones. And now we're going to keep these public access false. We are not going to expose this database to external world. So we have to keep this false. And over here, this security group should be database security group, and we have deselect the other one. Now, we don't have any preference. It can be 1A or 1B, doesn't matter. And rest, we are absolutely fine. Let's create the database. Now, this database creation will take a lot of time, but let it go on. What we will do in the other tab, we can go directly to ECS Elastic Container Service, and over here we can create the cluster. First, we need to create the cluster, and we can give the name as my app ECS cluster, and this is the AWS Fargate serverless, and this is the pay-as-you-go kind of serverless architecture that AWS is providing for orchestrating the containers. It's a serverless Kubernetes service offered by AWS, and this is not based on EC2 instances. You don't need to bother about the servers. The servers will be managed by AWS. So that's the beauty of Fargate. We are going to create the Fargate cluster. So both the database and Fargate clusters are being created. So let me pause my video. Once they are created, I will come back. All right, our ECS cluster and RDS database both are ready. Now we got some endpoint and we're going to note it down. And also our cluster is ready. Now go to this task definition and let's create one new task definition. Now this is going to be a template for our my app container. So we can say the task family as my task, and we're going to launch it on AWS Fargate. And we can minimize our memory requirement and the CPU, whatever the minimum um, is suggested. And this task role, we are going to say ECS task role that we had created at the beginning of this implementation or lab. Here we're going to create the new task role for the execution. Two roles are needed. One is task role and other is task execution role. Now this task execution role is a IAM role that is used by the container agent to make the AWS API request on your behalf, role to be created on behalf of us. Now here we need to provide the container details. We can say my app, and we can provide our well-known Docker image repository. So it's docker.io learning light my app v1.1. This is our my app Docker container image. And this particular image we created in the earlier lecture when we actually learned about containers and Kubernetes, and we learned how to push the image into the Docker Hub repository. So here we are having a couple of environment variables that we need to provide, and we are going to pull this particular image from our public repository from the Docker Hub. So over here, we are going to provide this URI, and we are going to say our 5,000 ports, because this particular app we actually run the Streamlit application on 5,000 port, and this is how we designed our application. If you have missed those videos, we are recommending you to watch those videos, how we have built this particular Docker image to run the Docker container. We kept the Streamlit application running from 5,000 port. We can say my app port, and literally we don't need to do anything other than add the environment variables. What we will do, we will just copy these environment variables and we're going to fill up over here. So DB user is admin. We created in our MySQL RDS database, and our root password is root123456. Next is DB host. So DB host, what we will do, we will just copy this DB host endpoint, and we will provide the host name over here. And the DB port, we are going to create the DB port. We already created at default DB port location. So that's it. We practically nothing to specify, and let us verify everything is looking good, and we can create this task definition. Once the task definition is created, we will actually create the service. Let's go to this cluster, and then we will create the service. Now, this service will basically the capacity provider strategy, and we're going to use this Fargate. We can keep 3, and in the task definition, we will use the task definition that we created. Maybe we can keep one name, my app service. And we're going to say desired task is 3. So 3 containers will be running, and these 3 containers will be orchestrated by Amazon Elastic Container Service. So this is the desired task. Every time ECS is responsible to spin 3 containers, and it will make sure that 3 containers are running all the time. Deployment options, we are fine. We are not going to change anything. Deployment failed detection. We are not specifying anything. Now, in this network section, here we are going to say we need to keep it in secured VPC that we created. And over here, we can keep these for all the subnets, all the public subnets for now. So basically, we are keeping these public 1 and public 2 subnet, and we are going to remove these private subnets for now. And let's use our ECS security group and deselect this default one so that this particular security group will allow the connection from the load balancer instead of from the external world. So this ECS security group is designed to accept the connections from the load balancer. Also, keep in mind that we have kept the external world open through this security group. And after creating the service, once the Docker image will be pulled and our service is created, our tasks are running, we will actually drop that inbound rule from this ECS security group so that this particular security group will be conservative. And we're going to create the load balancer as application load balancer, and our 5,000 ports will be mapped as 5,000 for the load balancer. And we are going to create the load balancer. We can keep one name like my LB, and here we are going to listen from 5,000 port. Everything looks good, and we can create. So right now, our containers will have the IP address, public IP address. To those public IP address, we could able to access our Docker container from the ECS, from the external world. Now, once our deployment is in progress, it basically created the YAML file and deployed in CloudFormation. So we can literally go to this CloudFormation and we can see what's going on behind the scene. So it created the target group, and now it is creating the load balancer, and we need to wait until this is completed. So let me pause my video. Once it will be done, I will come back. All right, all are completed successfully. So the CloudFormation template is successfully implemented. Now we can see our service is active, and if we go to the service, we can see a couple of tasks. I believe there will be 3 tasks. Yes, there are 3 tasks. And as we said that we need to have the 3 tasks running. So let's go to this task. And as we mentioned that we need the IP address, public IP address. So we got the public IP address. Now let us go to this public IP at port 5000. We can see our Streamlit application is coming. So these containers are actually accessible from the outside world. So that's fine, but we are not interested to have these access from the external world. Rather, we will go to the load balancer, we will go to this load balancer and just note that our load balancer actually got created, and at that time of creation we did not able to change the security group of this load balancer, and by default the ECS security group was assigned to these load balancers. So what we will do, we will deselect this load security group and we will provide the load balancer security group that we created. So let's save this one. And now let's copy this DNS name and paste in the browser, and let's access the 5000 port. And if we do so, we can see our containers, our ECS containers are actually accessible from this load balancer. And this particular load balancer is balancing the load between three tasks inside the ECS. Now, as you can see that our ECS container is accessible from the outside world. And for example, if we go ahead and stop this particular, like for example, this is 34, 22, 38, 83, 177. So if we go to our services and if we find our tasks, and this is our task basically, which is having this 83.177, this particular IP address, we can easily stop this particular task. And what it will do, if we go back in the service and if we check the services, we can see this particular task is going to be stopped. So if we say any desired state, we can see that one that we actually deactivated is going to be stopped right now. And very soon, this particular IP address will not be accessible once it will be stopped. So let's wait for a minute or so. I will come back once it will be stopped completely. Okay, let's refresh now. And we can see the one that we stopped, we will stop state, and one more task got spinned up, and three of them are running right now. So if we go to this website once again, and you can see the connection error because this task is not running, but our load balancer is up and running absolutely fine. So we can say item serial number 1, and we can say item is AWS, number 2, and we can say ECS, and number 3, we can say RDS, and we can click show item, and we can see the items are listed successfully, so the application can communicate with the database. Now, let's do some tricks. So far, what we have done, we implemented this load balancer security group, and this is actually allowing the user connection through port number 5000. If you put any ports other than 5000, it will not work. So we can go ahead and remove these 5000, and we can see it is no longer accessing. It will just go on and on and on, but it will not be accessible. Okay, so only port number 5000 is actually allowed from the external world to the load balancer. Also, we have the database security group, which only allows the connection from ECS security group to 3306 port. So we have kept everything very secure and specific so that no other connection from the external world or internal inside the VPC can reach to RDS or ECS containers. Now, the only concern is that our ECS containers are having one public IP. When it is alive and running, if somebody from the outside world is having that IP address, can reach to this ECS port through 5000. So let's paste that one. So we can go to this service and we can pick any of them. And let's grab this public IP, go to this browser, and let's type 5000 port. We are having these 5000 port accessible from external world because we are having this security group open for the external world for the ECS containers. So this particular access from the external world to ECS container through the public IP address should be cancelled. So what we will do, we will actually restrict this ECS security group to accept connection from the load balancer. So let's go to the security group. And let's go to this ECS SG. And we can see we are having two inbound rules. And let's edit the inbound rule. And we are going to keep this inbound rule be specific from load balancer to ECS. But we are going to remove this all TCP from the external world so that this ECS, any connection coming from outside to the ECS, directly to the ECS, will be restricted through this security group rule. So we can access this IP address through 5000 port as we have restricted this external access to directly to this task security group. Now, if we refresh this page will no longer be accessed because our the security rule is coming in between and rejecting the access. But our load balancer is fine. If we go to 5000 port, our application is able to be accessed. And we can click this show item and we can see whatever we are having in the database is still accessible. And even we can put the new item in the database and it is successfully inserted. Now let's go to this ECS cluster and let's steal some of the, or maybe all of the running containers, and we can say stop all tasks, and let's see what will happen if we do so. So we have asked to cancel all the running container. So the tasks are automatically got created. So if we go ahead and check this load balancer, it got temporarily unavailable. But once our services will be back, so one of the containers is back. And if we go ahead and refresh this page, we will certainly get our Shumlit application back. And we can click show item and we can see everything is running fine. So thank you for watching this video, friends. So in this particular video, we saw how we can spin up the containers in AWS ECS Kubernetes service. So this is a container orchestration service provided by AWS. And we have run our services on Fargate type of ECS instances. So Fargate is a serverless orchestration, container orchestration platform, and we have successfully run the application from our ECS Fargate service, and we created the MySQL private database, and securely we communicated to the databases from our application. So thank you for watching this video, friends. I hope that you have enjoyed a lot, and we will be back in the next lecture with some more exciting features of cloud engineering. Thank you. Goodbye. Be safe.